Okay, good afternoon. First of all, I would like everyone to close your eyes. And imagine you are in a factory and you are going to pick iPhone covers from a bin to a conveyor. Or you can do some quality inspection of a part for scratches or dents. That's not easy if you can't see. Okay, open your eyes again. If you were a robot, you might be pre-programmed. That's not easy. It takes some time and it's kind of static. But so if you were a robot and have eyes, I can see like human, and even you can see in the dark or in the bright environment, or if you can see all kinds of components. Wouldn't that be okay? My name is Arild Ulfeng. I come from a company called Zivid. It's a small startup, and what we make is this type of product. It's the 3D camera for robotics, so providing the eyes of the robot. So during this session, I would like to speak about the product, and I would like to give you some information about why we are making this product. I will talk about technology and what's under the hood of the camera, and I'll also talk about give you a brief description of the history of the company, and talk a little bit about culture and what drives great innovation. And I will round up with having a demo in the end, so real demo. So let's talk about the why we made this product. When I talk about industrial revolutions, first you had the steam machine, and then you have electricity and the beginning of mass production with Henry Ford. We had the invention of computer in the 60s and the beginning of automation. But what we have now is what we call the fourth industrial revolution. That's where computer and automation comes together in an entirely new way. So you have machines, devices, sensors, and people that are communicated. And the decisions are often distributed down to the devices around in the factory floor or in the warehouses. And that's our playground. And talking about robotics, so robots has been existing for many years, as I said, but in the past, those robots has been big. They have been expensive and not so flexible and difficult to use, and often there are big companies like automotive companies and such that can afford those robots and do automation. But the shift we see now in the market, it's towards what we call collaborative robots. So those are smaller and more flexible, so they can be moved around in the factory floor much easier. They are much easier to use, and then they can work together with people. So we think the key enabler to make this happen is 3D robot vision, because these robots, they need eyes and they need brains. So In terms of our product and the competition out there, we have in the one end of the scale, you have what's coming from the consumer. You know the Kinect camera, RealSense from Intel. Those cameras, they are pretty fast, but they also have low cost, but they have low accuracy. So we are talking about maybe in the millimeters. And on the other end of the scale, you have high accuracy laser scanners, typically. They are more expensive and very slow. So what we have tried to do with this product is to try to combine, to make it accurate and fast at the same time. That's kind of the uniqueness of the product. In addition, we also are handling color, so we're able to detect different colors. Inside the product, we have some filters. So, for example, if you should pick shiny objects, you might have reflections. So we have a filter that is removing reflections. For example, you can see there that you have one without a reflection filter and then with a reflection filter on. We also have, HDR. I guess most of you have heard about that in the camera, right? High dynamic range to increase the dynamic range of the image. So you are able to capture both bright and dark objects. So we have done that in 3D. So our product, it's a metal housing, it's robust. It also can handle, it's water and dust resistant. And also it can be either mounted onto a robot arm, or it can be kind of at the head of the robot, or it could be mounted stationary. If you like it, if you would like to pick something from a bin, you can place it over the bin. So some example of applications: bin picking. The robot with the camera can do a simple kitting assembly. It can measure different kind of objects, dimensional measurements. It can inspect if you have, sometimes you have people looking at parts to see if there are scratches and dents, right? Production errors. It can detect that. It can see the difference between unpick different red apples and green apples. And in the logistics, you can think about, you can pick and pack products coming from the storehouse. So many different applications it can be used for. So now you understand why we made this product and what it's used for and the capability. So now I would like to give you some more insight what's inside the product. And there are different kinds of 3D technology. You can have what we call time of flight. Those are typically consumer, and actually in the iPhone 10 you have a time of flight 3D camera. That's actually when you are sending IR and measure the time and the phase when it's reflected back to the camera. And that's high speed, but it's not so great for higher accuracy. But then you also have stereo vision when you are using two cameras. And you can have a laser scanner. So different kind of technologies. So what we have used is what we call structured light. So that's why we have inside our camera, we have actually a projector, what we call an optical engine. And we have a 2D camera, which is off axis towards the engine. So the engine is projecting multiple types of patterns, and the camera and the engine, they are calibrated towards a flat surface. So when the patterns are distorted, the camera can see how much is the distortion, and based on that you can calculate the depth. Okay, and in Zivid we have some design principles which we are following. First of all, quality and robustness, because high grade of reliability and stability in manufacturing is very important, because to reduce the downtime. If a production line is going down, it's very costly, right? Performance. So our ambition is to be leading edge on technology and to have the best performance. So what we try to do is to have the accuracy and the speed and the color, and that combination is very unique. We have flexibility, not that the products shall do everything, but trying to have a platform and features that is able to covering different types of applications. And simplicity is very important. That's because our customers, they are typically integrators. So they buy the camera, they buy a robot, they buy an analytic software package, and they are developing a system, a robot cell. That is that's a complex thing to do, and we are trying to put effort to make this more simple for the user. So to reduce the time it takes to develop a robot cell, but also if you think about, you should do different things with this robot cell, to make it simpler and easier to reconfigure and redeploy. When we did the industrial design of this product, that was an interesting journey. And what we have tried to do then is to humanize the technology a bit. So you can probably see that it reminds you probably of some of the robotic characters that are out there. So we have the projector on the camera is kind of the eyes, and you have the heat sink as the kind of the hair on the side blowing in the wind. You might see the nose and the beard. So trying to humanize that. But the main thing about industrial design is that you need to design it from inside out and the outside in at the same time. You can't do the industrial design and then figure out what parts that is going into the product. That's important. That's the key learning. So if you look at under the hood, you can see there is the camera and the projector, and there's a lot of optics in the camera. So we are putting a lot of effort into optimizing the optics, and also now we are doing our own design because we see this as a critical components to have the really good performance of the product and stable. The controller board is. So first of all, we are using the PC. So what we are doing with the camera is providing information of the 3D coordinates, so X, Y, Z, color and contrast. We're sending that to the PC, and the GPU on the PC is computing the point cloud, the 3D model. So. But we have on our controller board, we have a microcontroller, and we have also on our latest version we have put quite a lot of sensors because they don't cost anything, right? So we put in accelerometers, we put in humidity sensor, temperature, pressure, and that's for we don't know everything we are going to use it for, but that open up opportunities for new features. And you can think about diagnostic, for example, will be important when it's in the market to try to understand what the products are used for. The temperature, the pressure, the orientation. It's interesting information which might be used for later. Yep.
So So the projector and the camera, is that stuff? Is that what you're designing yourself?
Currently, we are doing the projector. Yeah. So, but for this, this was kind of a semi-custom engine, I would say. So it's kind of based on a Pico projector, but we did some modification to it. So what we're doing now is more custom, going forward. Yes, to have more stability and to have better optical performance related to temperature, for example. Another key findings was, to invest in test equipment, because we don't have the time, to be in a queue at the third-party test house. So we are thinking short iterations, and you need to test and get feedback on what you are building. So we are trying to invest in test equipment in-house, to shorten time to market, but also to improve quality. So in terms of software, in Zivid we have a small, young, and international team, I would say. Our main language are C++. We do have an agile workflow with daily meetings. We have trying to keep the repository clean and doing feature branches. We are doing pull requests and code reviews. So it's kind of a high degree of automation, and we try to document in the code, typically agile way of working. So using modern C++, so what we deliver is C++ 11, but we also, internally we are, using features and looking at C++ 17. So it's not the black and white thing, but not to include all the customers, we are using C++ 11. It's a cross-platform, so it compiles on both Linux and Windows. And we are also GPU. We have put a lot of effort into GPU programming because the capture time is important, but also the processing time, right, on the GPU. So it's the whole chain which is important. So optimizing the GPU is something that we do. Trying to have simplicity as the core value. So we are providing APIs, for our customers, so they can program in Python, .NET, or GenCam. So we are making having the C++ as the core, but providing APIs in different languages, trying to find the right balance between reusing the core, but doing wrappers, so developers are familiar with the different languages. And only a few lines is required to capture the first image. So it takes continuous integration serious. That's for best quality and speed, and using Jenkins pipelines with the various type of Dockers and VirtualBox images for Linux and Windows. It's built and tested on Ubuntu, Linux, and Windows. Different kinds of compilers like Clang, GCC, and MCVC, and we also use different kinds of modern tools to have a broad test coverage. So, the first year or two was make sure we fix the stability, the quality, the compatibility. That's the building the foundation and the platform for future use. That has been our focus. Now we are trying to broaden up and focus more on machine vision to make things simpler for the user, but also to improve the performance. So we are, working on APIs with different kinds of tool sets for the user in machine vision, and also looking into AI, to use that as the technology to do improve the performance, for example, the speed, and to handle different objects where you don't have a CAD model to compare it with. Different things in that. Okay, so that was a little about technology. So now I would like to go through a little bit the history of the company. So Zivid is a young company. It was founded by these two guys, Henrik Schumann Olsen and Øystein Skotheim. They were SINTEF researchers, and they've been working together for 15 years in SINTEF, which is the largest research institution in Scandinavia. So they actually been working with machine vision and automation and robotics for a long time, right? But they were software people and developed algorithms, but they saw that there were not a really good sensor in the market that were both accurate and high speed. So that's why they made a prototype with some help of from consultants. They used the rest of their project money to have a stand or a booth in Vision in Stuttgart to test this product, and the feedback was fantastic. So they got a lot of good response. So when they decided, no, we need to go back and establish a company. So that was the start. So the company was established 3 years ago. Yeah, here is we are in the prototype phase, and more people are coming to the team. And you might wonder why we put the product in the fridge. So the thing that we actually discovered when we had the first prototype and started to test it was that that it's an optical engine. And LED, they are generating heats, of course, and things were actually not stable. It was expanding, right? And that's not good for a camera that should have an accuracy of 0.1 millimeter. So we were looking at the calibration and figure out we had to calibrate for different temperatures. So we had to cool down the unit to 10 degrees, and up to 50, heat it up to 50, and use different kind of calibration for every temperatures. So by that we were able to solve that problem. So it's a good, and also we optimized the cooling system from a hardware perspective. So it's a good example of software and hardware coming together to solve the problem. We were very creative. We tried to cool down the unit. We bought ice cubes from the grocery stores. That's not something we can do in production, but it worked for a prototype. But a lot of creative ideas, to solve these problems. Here you can see we do vibration testing, the easy way, and a bit more sophisticated way. And it should resist water, so we were having some creative methods to test it for water ingression. So why don't pour the water inside the unit to see if it doesn't come out, the water? So that was things we did. But we finally tested it at a test house, so it was more according to the standard. But that was, when you're a startup, you need to figure out things like that, right? And calibration is an important part. This was in the early we did a very simple calibration with a plane at the bottom there. But now we have more sophisticated calibration system where we have a ventilation control and also are correcting for temperature, but also for optical errors. So, for example, we have an industrial cooler that we need to build a room for. So it's more sophisticated and more expensive, but it works. So a lot of challenges when you are a startup, right, and making a new product. So another challenge we had was to get attention from our suppliers or partners. So, for example, we were using this engine, and talking to these guys in Asia, they are building maybe 500,000, 1 million projector or engines per year. And then we come, a small company, 5 people, we like to buy 100 this year. And by the way, we need to do some modifications. That's not easy. So that's why we needed to go to Asia. I think we have been there maybe 7 or 8 times over the last couple of years. You need to build a relationship. And what you need to sell is not the 100 that we're going to buy 100, but need to sell the potential in the market. You need to think robot eyes to the eyes to the robot. So by doing that, we get more attention. But it's about the relationship, and need to be there face to face, and also to go through, problems that we need to solve together. You can't do that on email. You need to be there and go through it with them on the whiteboard. That's fairly important. Here's another example of challenge we had. This is the profile, or the enclosure. So it's made by technical extrusion. So it's kind of an aluminum block, which is heated, and you push the tool, and then it comes out a long profile. But the problem that we had was when it was cooled down, one side was kind of bending more than the other, because we have more material on the one side. So we ended up by adding more material to the whole enclosure and grind it off after. It's expensive, but it works, and it's So a lot of challenges there as well. Yeah, this was a proud moment. We shipped the first unit and built and shipped by employee number 3 and 4. And the guy who built the first products in the lab went to the partner that should produce the product, and kind of acting as the production manager. Another thing, when you're a startup, you need to do all kinds of things. So during these trips to Asia, we used the opportunity to talk to potential customers as well. Selling, so put on the suit and selling the product as well. And we met these guys as well. They were selling this climate chamber, which we ended up buying, and to 1/4 of the price compared to Norwegian price. So we were located in the Startup Lab, which is a tech incubator in Oslo. It was really good. Okay. Sorry. An incubator where you have 60 and 78 companies struggling with the same things. It's really good, to be there and discuss and talk about the same problems we have. Really good. Yeah, we had hot dogs on every Friday. A lot of fun. We were out in the field, a lot out in the field, on the exhibitions. Here you can see Henrik is doing some creative selling. We actually made a trolley. So we were rolling this trolley around in the exhibition floor, trying to attract people. Because you have this blinking, right? So it's easy to attract people. So that was creative selling. This was US, so we expanded to US early this year, and started to sell there, and we attended the Vision Show, and we got this prize which for the best 3D camera. And of course, we have a lot of fun. So we are a small family, and going to Hemsedal or things like that is very important for a startup, to get this good feeling. All right, so we have a product, award-winning product. So what I'm going into now is, to give you some my take on what drives great innovation, and that's not based not only on the 2 years I've been working at Zivid, but also I used to work at Cisco, leading development there. And whether you are a small startup or a bigger corporate company, there are a few things that are important. So, first of all, you need to have the right people. Number one. You need to have the right people with the right skills, the passion, and the engagement. That's the most important. People that can drive, the engagement and really do the improvements. The second is the purpose. So while you can think people could be the DNA of the company, the purpose should be the religion, because you need to have the direction, you need to have the strategy, and you need to have the purpose. Why are you making this? And you need to understand, what type of problems you will solve for the customers. So with the people and the purpose, and the third thing is the culture. So culture is important, but it's about how you're working together. How are you solving the problems together? So that's so now I'm going to talk a little bit about the last thing, the culture. And you've probably seen this before. Some of you have, I guess. Conways Law. Basically, it says how you organize your team and how the communication is going between the teams and people will shape your product. And I think that's not only for software, but it's for hardware as well. You need to find, the right communication structure. That's because it will reflect on your product, how it will be. So I think, focusing on and follow Conways Law, organize into product and feature teams to have this close interaction between disciplines, self-directing, quick decisions, and so on. And we need to keep the focus, need to understand and solve the real customer problems, and think user experience then. The second is to think agile, not only in software, but in hardware as well. Need to have this progressive development with short iteration. Be visual in your development. Use demos, use moonboards, animation, videos. And this is to get feedback, right? To build and have short iteration and to get feedback on what you build. And that can be testing for internal, to get feedback from internal people. It could be testing with temperature or whatever, and it could be testing and checking out at the customer. You need to have goals, because if you don't, and you need to track them, because if you don't know where you're going, you will never get there. So to have goals from bottom up and top down, and which are aligned with strategy and direction, need to be measured, and it's cool to take some risk, to have some high potential goals, and need to have regular check-ins and to understand where everybody are. The last thing is about empowerment, and I think it's coming with the ownership. You need to have ownership of what you are working on, and to be involved early on, and value doers. And I think empowerment is something you get, it's something you take. So here it's about having the right people again, with the right passion. So where do I see the future of Zivid? Okay, so we have a good sensor, a 3D camera. We will go into machine vision and adding more features to our product, taking more ownership of the brain. But most importantly, I think to build a great team is the most important. To build a great culture, a great learning culture, is the way we are going to succeed. Because everything else can be copied, but culture cannot be copied. Thank you. So, let's see. I need to end the presentation and it's here. Let's see if I close this, maybe it helps. Yeah, I tried it before, so it should be show up here. Strange. If I do that like this, then cheating. Okay. Yeah. So let's see. We can do capture. Okay, I have it here now. Yeah. So this is now I took a capture and I took 100 milliseconds to capture it. So what you see, the resolution on this projector is not good. So you can't really see the high accuracy, but you get the sense what it can do. You see, every these dots have a 3D information, and you can rotate. We can do live. So now it generates 3D point clouds every second, 10 3D clouds. I can turn off the color so you can see it's better to see what you get when you get data when you turn off the color. And you can let's see. Let's try HDR. I have a white and black object there. So if I do you can't really see the black one, right? There's no data there. But if you do HDR, combining different images, you can maybe see. You can see it here. You can see it there on the projector. But let's see. Try to.
You can see it on the depth image.
Yeah, you can see it a little bit there. It's not easy to see, but let's see if I can decrease. Yeah. Put in this as well. Okay, add. Yeah, it's easier to see now. But I'm blaming the projector. So this is when you do HDR. Yeah, and we have things like, as I said, the reflection filter, which is actually on, which it shouldn't be, but we have that. So that's more for shiny objects. And let's see, maybe one, can I have a volunteer guy? You? Okay, come up. Do you want to have do a selfie? The coolest selfie ever. So if you can be there a little bit, yeah, you can see, and you can see, look in the camera there. You can see. Yeah. So basically, with 0.1 millimeter, you can actually see the difference between here. Here is about 0.1 millimeter. It's not easy to see on this projector, but you get yeah. Okay. Thank you. Any questions? I think we have 5 minutes. Yep.
So, you say this could be used for like collaborative robots. But this blinking, have you looked into the what that would be around the blinking all the time?
We haven't actually got any negative feedback on that because in most cases this blinking happens not regularly. So maybe a blink if you have a robot that is going to pick something from a bin, maybe you have a blink every 5 seconds or so. So it's not. We haven't seen that as a big problem, but it is possible to use IR as well. Yeah, it is. Yeah.
What is the resolution on the camera?
The camera is 2.3 megapixels. So every pixel has the XYZ 3D information.
What are you offering to? What's the outputs there? Is it do you supply the software to generate the point cloud as well? Or
yeah. So we're providing the APIs. And this is just an SDK, just for demo and such, but we are APIs. So what we are actually providing is the point cloud, the 3D model. So you need to have some analytic software on top of it to actually figure out what to use it for and tell the robot what to do. And that's what we are also looking into. So we're trying to in the future, do some more features, analytic tools. But you can buy these analytic tools from third-party software houses. Yep.
You talked about using it for manufacturing, checking out lead pipes and stuff like that.
Mm-hmm.
How does it work with shiny objects? I guess when you make this pattern,
yeah.
it just disappears and doesn't reflect.
Yeah. Ambient light and reflections are difficult conditions, but we have filters that are removing reflections. So we are actually pretty good at handling shiny objects. So car industry, for example, they are using a lot. So yeah, we have algorithms that are handling that.
Those are digital filters, not polarizing filters?
No, those are digital filters. Yes. It's also related to how you are projecting the patterns. So we have different patterns. For example, we have patterns oriented different ways. And in addition, there are also other magic stuff in there, so, which I don't know all about. Any more? Okay, thank you very much for your attention. Det var bra. Gøy å høre på deg. Takk for det.